Hello, everyone. In this lesson, we're going to build on the concept of functions by taking a look at how we can write our own functions. It's a really important lesson in terms of your growth as a programmer, because from this point onward, a lot of our programs are going to be broken down into functions that we write for different tasks. So, to bring back some ideas from the last lesson, you want to be thinking in terms of what's called top-down design now, where you start to break your program down into smaller subtasks, and each of those tasks tends to become its own function. And a function acts a lot like a small program. It'll take input, oftentimes produce output for you, and it's almost like a program within a program. You've seen a function, the main function, and we're going to build on that in terms of how you can write your own functions that return values for this lesson and functions for other tasks in the later part of this unit. Creating your own function is really involving two stages. You'll have to declare the function, a lot like declaring a variable, although much different syntax, and then define the function where it actually does the computations for this part or performs its task. And once you've both declared and defined your functions, you can start to use them in terms of function calls from main or even from other functions. So the first concept we'll talk about is a function declaration. So in order to use your own function in a C++ program, you must first declare it. Like if you want to use them in a variable, you have to declare that variable. And a function declaration is a C++ statement, which means it will end in a semicolon. The declaration is going to give somebody enough information in order to how to use that function. So a declaration will establish what type of value you can expect to be returned from that function, be it int, double, char, bool, the number of inputs and their types, and then also the function's name so that somebody knows how to appropriately call that function. So a function declaration is going to go between the hash include IOStream and the int main part of the program. So proper style would place them there. And the reason your function declarations have to go before main is because in order to call a function from main, the compiler has to process that function name exists before it gets there. If you don't put your function declarations before main, you're going to get errors in main when you attempt to call them and refer to their names. Similar to if you didn't hash include the appropriate library and attempt to call the function from that library, you're going to get an error. So any function you're writing yourself must be declared before main. So let's take a look at writing a function declaration just using a concrete example. Let's suppose we want to write our own function that finds the volume of a cone. The formula for that is 1/3 pi r squared h. The questions to consider in designing a function are how many inputs are there and what type are they, what type of return value would go with the function, and what's a good descriptive name for your function. So for this particular function, you need two inputs, each of type double, one for the radius and one for the height. You can also expect to get a double value back for the volume, and a descriptive name would be something like volume cone. So our function declaration statement is going to capture all of that, and here's what it would look like. You could either write double volume cone, so double is the return type, volume cone is the name of the function, and then in parentheses establish the type and oftentimes the name of the inputs to expect to the function, so double radius, comma, double height. A declaration doesn't technically have to provide names to the input. It has to provide at least types, but it's a good habit to just provide names for what the inputs are at this point, and you'll see why. And again, a function declaration is a statement, so this would end in a semicolon. So to add the declaration to a program, you would put in the line double volume cone, double radius, comma, double height with that semicolon. So now we know that this function is going to exist somewhere in this program. And notice the use of the semicolon again. This is a C++ statement. Your declaration must end in a semicolon. It's a lot like declaring a variable, just a higher level of it in a way. So important vocabulary. The return type is indicated by that first keyword. So double indicates the return type of the function. What kind of a value is this function going to compute and return to us? So double numerical with decimal precision. Volume cone is the name or the identifier of the function. Again, be descriptive, just like declaring variables, you want descriptive function names. And these two, double radius and double height, radius and height are the names of what are called the function's formal parameters. So in this case, each parameter has a type, which would be double, and their names are radius and height. Formal parameters are essentially placeholders for what you're going to plug into the function, whatever input values the function gets. Now, to actually define the function after you've declared it, the function definition is where a computation or another task might happen. The function definition will go after the main function. It's like the best style to use. So declare your functions before main, You'll have your main function still, and then the actual function definitions will go after main. So a function definition is a block of code with a heading that really mirrors the declaration statement. So if you write a good declaration, including the type of the function, a good name, and provide names for the formal parameters, you should just be able to copy and paste that and use that as the heading for the function definition. Now, when you're defining the function, there will be no semicolon at the end of the heading, as you see here, and you have to have names for the formal parameters at this stage. So I think it's just a good habit to declare a function with names for the parameters. That way you don't have to think about it later on. You kind of already done the thinking process up front, and you can just simply make your heading based on that. So the other important concept is going to be this return keyword, and you've seen this before. You just may never pay close attention to it. Main is a function in every program that returns an integer, and at the very end of it, it returns the value 0. It's just a convention for things going well for the main function. So our functions that return values will use that same return keyword, and they'll return some appropriate value that matches the return type of that function. So in terms of organizing, writing a function definition, it's not a bad habit to, for your own functions, declare a variable that has the same type as your function, do some computations that assign an appropriate value to that variable, and return the name of that variable at the end. Then we'll go through that as our way to write the definition for our cone function. So here's what a good definition would look like. Notice again, we have the heading, and I'm using the style of declaring a variable, assigning a value to that variable appropriately, and then returning it. So double vol is what's sometimes called a local variable. The only place this variable exists is within this function code block. It's being used to hold on to the value I need for the volume. I'm assigning, using the formal parameters, radius and height, a value to the volume. So make sure when you write a function definition, it only really knows about the variables you declare inside of it, like vol, and its formal parameter names, radius and height. And then at the very end, there's a return statement for the name of that variable vol. So it's going to give back a double value to whoever used this function. Another style you could use is like this. You could put the computation in one line. Feel free to do this, but I think in terms of how complex your function is, you might want to do the stage of declare, assign, and then return, but this is totally fine as well. You can make a lot of functions that return values be one line if there's just one computation happening. And you'll notice it returns the value of a double. You can perform the computation within that return statement. So some important vocabulary to recap as part of the function definition. The entire code block here from the heading down to that last closing brace is called the function definition. The first line here is the function heading. So that mirrors the declaration. It's just a heading for this code block. And between the braces is sometimes referred to as the function body, where all the actual computations and whatever else the function does as a task is accomplished. So here's what a finished product would look like, both putting the function definition in, putting the declaration in, and actually using the function in main. So I have a little bit more added here. And let's go through the different aspects of this. Up here again is our function declaration, C++ statement with a semicolon that says there's a volume cone function in our program. Down here is our function definition, the actual code for computing the return value for our volume cone function. And then in main is a call to that volume cone function. So that's actually using that volume cone function in a statement. And we're plugging in 3 and 2.5. Those are called arguments. So there is a distinction between the values you plug in, they're called arguments, and the radius and height, which are called the parameters. And we'll go through that distinction a little bit more, but arguments are your specific inputs. We're plugging in 3 for radius, 2.5 for height, and then radius and height receive those. Function does this computation, and you would see the volume printout for this. Now, you don't need to plug in specific values like 3 and 2.5 in the last slide. So again, that last slide, we specifically hard-coded 3 and 2.5. You could plug in the name of a variable that matches the type expected by the function. So you'll notice in this one, we prompt the user for radius and height. And then in the output line, there's just a function call with the arguments r and h. So notice like r and h are being used to hold on to the values the user wants, and then we'll plug in r and h. And those values that the user input would go into the function for radius and height. So again, an argument to a function doesn't need to be a fixed numerical value like we had in that first example. It can be the name of a variable that matches the value the function expects. So To recap an argument versus a parameter, an argument is the specific value you plug into or substitute into the function when you call it, whereas the parameter is the placeholder for when you're writing the function definition for what the input values will be. So the names of the formal parameters you're going to find in the function definition heading. An argument you're going to find in an actual call to the function. So back on the previous slide, the arguments in this program would be R and H in that call, and the formal parameter names would be radius and height. An analogy from an algebra class would be, consider f of x equals x squared, a mathematical function. X would be the formal parameter. That's just a placeholder for what you want to plug into that function. Whereas, say you wrote f of 5. 5 is a specific input or an argument. So that's the distinction. An argument's a specific value or input, and a formal parameter is the broad placeholder for the actual function definition. So to recap the function concept, think of a function like writing a small program. Calling a function is a lot like running a mini program. Your input to a function will occur through its formal parameters. You'll notice in the function definition that we wrote, there was not a single cin statement within the function definition body. For functions that return values, typically the input happens through its formal parameters, and the cin will happen elsewhere. The arguments in a function are just plugged into those formal parameters, and the output a function gives you is typically not going to be within a cout statement in the function body itself. Somebody else is probably going to do the cout statement, like the main function. The output of a function happens through its return statement. So I'd like to pause and have you write your own declaration and definition for your first function. So using the notes you just took on that volume cone function, match them to this scenario here. I'd like you to write a declaration and a definition for a function that's called volume sphere. It's going to have one double parameter for the radius. And what it will do is just compute and return the volume of the sphere. You don't need to write a full program. And you can assume the CMath library is already in here, so you can use the PAL function. So please pause this video and write the declaration for this function, that one C++ statement, and the definition, starting with both the function heading, right through to the end of it, that would compute the volume of the sphere. So, and we'll go over this in a minute. So again, please pause. So hopefully you've took my directions and paused and practiced this. You're going to be doing this a lot, and the problem set is just declaring and defining functions. And then when you start coding with functions, you'll get this habit down of what a declaration looks like and what a definition looks like. So a declaration for this one would be double volume sphere and then double radius. The name volume sphere was in the directions, which would be why you'd use that. And even the radius parameter name was in the directions. And then the definition, you'll notice, has that same declaration line, but delete the semicolon to use that as a heading. The open and closing brace, and then the style of declare a variable for the return value, assign that variable appropriately, and then return the value of it. Some details. Be careful of the 4/3. If you wrote 4/3, that'd be integer division, and precisely be treated as 1. Make sure it's 4.0/3, 4/3.0, or even do a cast to a double within there. And then, like I said, assume the CMath library is in there to use the PAL function. So very important lesson in terms of your future in programming. From now on, you're going to be breaking a lot of tasks into these functions, so definitely take some time to understand the difference between a declaration and a definition, how to appropriately call your own function from main to. There's a couple of good demo videos we'll go through after the problem set of actually coding with functions too. Okay, so hope this was helpful.